Hello everyone, in this video we will study the international Fisher effect theory, but before doing so let's look at the original Fisher effect theory. You may learn this theory in say Econ 101. The idea is that there is a direct relationship between interest rate and inflation. If there is high inflation going on or high expected rate of inflation, now the bank have to offer high interest rate to attract depositor. For example, if the inflation is 3%, clearly the bank should offer or have to offer you an interest rate more than 3%, right? Assuming that it offer you say 5% deposit rate, your return, the nominal return is 5, but you know for sure that your real return is less than 5. But how much is that? You can use the Fisher effect to calculate the real return. The formula is nominal rate equal to 1 plus the real rate multiplied by 1 plus inflation rate minus 1. Okay, you plug the number in. 5 is nominal return, 3 is expected inflation, and therefore you can easily calculate the real interest rate, which is 1.942%. This one is a full formula. Manipulate the formula a little bit. We come up to an approximation formula for Fisher effect, and it is stated nominal interest rate is approximately equal to real rate of return plus inflation. And yes, when we plug the number in, you can see that the real rate of return should be about 2%. Okay, and the approximation and the actual and the exact number is, close enough, right? So now let's look at the international version of Fisher effect. The international Fisher effect, or IFE theory, stated that the real rate of return on an investment in country A should, on average, be equal to the real rate of return on similar investment in different country, say country B, assuming that the two investments are similar and the risk level are the same. So basically, if you have two similar projects and if you invest in A or B, regardless of which country you choose, the rate of return should be about the same, right? Should be equal, about the same. It means there is no free lunch. If you want higher return, there must be different. You may have to assume more risk, okay? Expose yourself to more opportunity, a better investment opportunity to get a better return. If they are similar, you should have the same return. That is the idea behind IFE. Now that leads us to the following argument. The country of high interest rate should exhibit high expected inflation according to Fisher effect. And then the high inflation here, according to the purchasing power parity, suggests that currency should depreciate. Okay? So you see the connection of interest rate, expected inflation, and currency, how the currency change. Yeah. The flow chart here just repeat what I just discussed. Okay. High rate, high interest rate suggests high expected inflation according to Fisher effect. High expected inflation lead to currency depreciation according to purchasing power parity. And similarly, over here you have the flow chart for low interest rate and the currency appreciate. And the middle step is low expected inflation. So you can see that international Fisher effect work closely with the purchasing power parity. Okay, so here's a story. In the, say, February 2007, Zimbabwe inflation is more than 50% per month, and of course it offers a very high interest rate on deposit. In the US, on the other hand, inflation is stable and deposit rate is less than 0.1% a month. So do you want to invest in Zimbabwe or you want to invest in the US? Okay. So over here, if you want to invest in Zimbabwe, first of all, you have to convert US dollar to Zimbabwe dollar at today's spot rate. Invest and earn more than 50% interest rate, right? And then you get back a lot of ZWD, Zimbabwe dollar, right? However, what will you do? Clearly, you have to convert it back to US dollar, right? The question here is, when you do conversion, what is the exchange rate? We don't know, okay? It's one way to invest money. Another way is safer and simpler. You simply invest or deposit in the US and earn 0.1% a month. And here you go. You get back US dollar at the end. Okay? So the international Fisher effect say that if those two investments have the same level of risk, the return should be the same. Okay? Now let's see. In the next slide, I put the return together. So the return earned if invested in the US is very clear. Interest rate in US dollar, right? The return if invested in Zimbabwe will be equal to 1 plus the interest rate in ZWD times 1 plus change in the value of that currency minus 1. So now Fisher effect say these two returns should be the same, and therefore we have the yellow box, the same as the green box. We add both sides with 1. Right? So the left-hand side is that, and the right-hand side, -1 is gone. Right? Finally, you divide both sides by that factor. So on one hand, you have that one left over. On the other hand, you have the interest rate in the US plus 1 divided by 1 plus interest rate in Zimbabwe dollar. Okay? And then you take off 1 on both sides. So this side, this one is gone. All we have is change in the value of Zimbabwe dollar equal to interest rate in dollar plus 1 divided by interest rate in Zimbabwe plus 1 minus 1. Okay, now what is the idea? What is the idea behind this formula? First of all, it is the exact formula for IFE. Okay, to see the logic better, okay, we can look at the simplified version of the IFE. People do a little bit manipulation and the formula become change in the value of Zimbabwe dollar is approximately equal to interest rate in dollar minus interest rate in Zimbabwe. Okay. Now it covers one thing. If in Zimbabwe the interest rate is very high, okay, compared to the interest rate in the US, what should happen to Zimbabwe dollar? You say 1% versus 100%, right? So it will be negative 99%. What does this mean? It means high interest rate in Zimbabwe suggests that inflation in Zimbabwe, or imply that the inflation in Zimbabwe is expected to be very high, and therefore the change of Zimbabwe dollar is negative. In other words, Zimbabwe dollar depreciate in the future. Okay? Now, here's something that very easy to make mistake. First of all, the currency we are talking about is the value of 1 Zimbabwe dollar, and the change is Zimbabwe dollar, and the interest rate is in the bottom. Okay? And in the approximation, the change is still Zimbabwe dollar, and the interest rate is the second factor. If you switch the number or you switch interest rate, you will get a wrong answer. It is very much similar to the purchasing power parity problem I stressed repeatedly in the previous video. Let's look at an example. Assuming that the nominal interest rate 1 year in the US is 9% and 6% in Japan. Assuming that the real interest rate is 2% in each country. So now what we can do is we can calculate the inflation or the expected rate of inflation in the two countries according to the original Fisher effect. So expected rate of inflation in the US equal to the nominal return minus the real return, approximately 7%. The same thing, nominal minus expected inflation, so the nominal return minus the real return, right? So the expected rate of inflation in Japan is 4%. So 7, 4. Now, how the value of Japanese yen change during the 1 year? We have to apply the purchasing power parity, and I copy this slide from our previous video. So you pay attention to the currency we are analyzing. Change in the value of Japanese yen approximately equal to expected inflation in the US minus expected inflation in Japanese yen. And you plug 7% here and 4% here, and therefore you can see that Japanese yen should appreciate, Japanese yen should appreciate by 3%, okay? Now, if the spot rate for Japanese yen today is 1 cent, what should be the value of Japanese yen 1 year from today? So we apply the formula. The future spot rate for Japanese yen equal to today's spot rate multiplied by 1 plus the change. So it equal to today's spot rate is 1 cent times 1 plus 3% we learned from previous slide. So you plug the number in. Here we go. The future spot rate for Japanese yen is 0.0103. It means that Japanese yen appreciate from 1 cent to 0.0103. In other words, Japanese yen appreciate by 3%. Okay? So it consistent with our idea is high interest rate in the US imply high inflation, and therefore US dollar should drop. Low interest rate in Japan imply low inflation, and therefore Japanese yen appreciate. Okay. Second example. The nominal interest rate is 5% in US and 6% in Canada. Assuming that the real interest rate is the same in both countries, and normally in our book, normally we assuming that the real rate of return is the same in all countries. Okay. So in that situation, because we don't know the real rate, we cannot calculate the exact expected inflation, right? However, we still can calculate the difference in expected inflation. We cannot find the exact, but we still can calculate the difference. So let's see how it works. According to the Fisher effect, US expected inflation should be nominal return minus the real rate. The same thing in Canada, expected inflation should be nominal return minus real rate. And now, here is expected inflation in the US. Here is expected inflation in Canada. Apply the purchasing power parity, okay? change in Canadian dollar equal to expected inflation in the US minus expected inflation in Canada. You plug it in here. You open the parentheses and you will see that, okay, real rate is gone, and therefore percentage change in Canadian dollar is what? Negative 1%. Canadian dollar should drop by 1%. It makes sense, right? Because the story is high interest rate in Canada imply high inflation, and therefore Canadian dollar should drop. Low interest rate in US implies that inflation is expected to be low, and therefore US dollar should go up. Okay? So let's see. Continue our previous slide. Over here, I suggest that when when the real interest rate are the same, we can skip PPP step and use the IFE right away. In other words, here's the IFE, okay, IFE approximation. Let me show you again. Before we get here, approximation here. Change in Canadian dollar equal to interest rate in US minus interest rate in Canadian dollar, right? So let's go back to the dollar. Change in value of Canadian dollar equal to interest rate in US minus interest rate in Canada equal to 5 minus 6% equal to 1. So again, when the real rate of return are the same, we just use international Fisher effect formula right away. The last one, okay? So in this case, we're working with two currency, different from US dollar. Assuming that the nominal interest rate is 5% in Canada and 7% in UK, also assume that the real rate of return is the same. Current spot rate is £1 equal to 145 Canadian dollar. So let's calculate the exchange rate 1 year from today. Okay. As we discussed before, because the real rate is the same, we can apply the IFE formula right away. In this case, now be careful. In this case, we calculate the percentage change in pound equal to interest rate in the other currency, which is a CAD, minus the interest rate in pound. So again, we have to pay strict attention to which currency we analyze and the order in the formula. Over here, I copy from our previous slide of international Fisher effect. The currency we analyze need to be in the second place, and the exchange rate we analyze must be in that formula, in that format, okay? So we look at the exchange rate of £1, we analyze percentage change of pound, and the interest rate of pound stay in the second place. That is the most confusing part, okay? And now it's easy. Add 5%, pound 7%, so change in pound is negative 2%. In other words, pound should depreciate against CAD by 2% during 12 months. The future spot rate 1 year from today equal to today's spot rate times 1 plus the change equal to today's spot rate of 145 times 1 minus 2%. Yeah. And it equal to 1.421. It means that the value of pound dropped from 1.45 CAD to only 1.42 CAD, and this depreciation is associated with 2%. And I mean, it makes sense because UK offer a high interest rate. It implies that inflation in UK is high and therefore the UK pound should drop. And in terms of the number, we just did it. Thank you. I hope it helped.